Hey, good morning, dear colleagues. Let me share some learning from last night's beautiful dinner experience I had in the Saïs house. And about 2 months ago, so we were having, let's say, an all-employee face-to-face meeting in Germany. So people flew all over the globe to join this workshop. Then we had an external speaker from PCH Innovation, which is a similar innovator in the Berlin ecosystem. Then he gave me the feedback. Look at you guys, all dressed up in the business casual. Are you really doing the innovation? So I took it as a good advice. So second day, I dressed in a jeans, sneaker, t-shirt. I brought this understanding to Bay Area yesterday. So I was, again, flying in with business suits, with customers. Then I talked to myself, go to Said's house. I imagine the full house of the startups, innovators. Guys must be dressing in a crazy way. So I showed up with my sneaker jeans, then I figured out like 70% of people there. Who of you were there last night? Just raise your hands. Okay, so good, majority disappeared, so I can say this. So what the heck, you dressed up for innovation evening? So I felt I was the minority. As human beings, we have nature, you look for the similar groups. That means if people look like you, behave like you, speak like you, you tend to get closer, right? So I did the same thing. So I ended up in talking to another guy in jeans, sneaker, and asked him, what's your name? Gary? I hope he's here. Which company do you work for, startup or corporation? Chicken Filet, right? Familiar name. I said, wow, that's the favorite restaurant of my son. Then I talked to myself, what brought you here as a food company? Why you showed up in the Silicon Valley? And Gary shared, we have a few headaches. Business grow very good, but we look into the future. Food safety, user experience or consumer experience, as well as the digitalization, how it can transform to have the smarter and quicker kitchen. That's exactly the same to our industry, or we call it here vertical energy. We also care about this energy safety, right? Better you do not have the blackout. I see the elevator out there is out of order. Hopefully it's not because of electricity, it's mechanical problems. Now, we also need digitalization. I will tell you why in my talk later, as well as user experience, okay? But before I really bore you with the energy topics, because we are in the Silicon Valley, I was upstairs. I was looking at the map of all the innovation. Majority are either IT companies or telecommunication companies, hardware, software, the whole infrastructure. So I try to make an analog to the energy system so you get the idea why we are talking about energy transformation here. Telecommunication, by definition, tele means distance, right? Geographic distance can be the time difference as well, right? You talk to yourself after 1 year, that can happen. Then communication would be people communicate to another person by audio, by body language, visual, by language in writing, all the ways. Then over there, let's say if we roll back many, many hundred or thousand years ago, then people basically have this language without in writing, right? Talk to each other. But if you really want to talk to somebody thousands of miles away, then old way of doing things, you tell a messenger. The messenger will, ride a horse, go back to the other side, then tell the other person. And later the language was invented, and you have the letter, you have the post industry, popping up. Now later it's get much more complicated. That's why you have all the infrastructure for all the social media today, Twitter, Facebook, WeChat, you name a few, with all the audio, video, text. And the whole system gets much more complicated around very fundamental human being needs. That's communication, right? But the whole system can become extremely complicated. That can trigger a lot of business opportunities. This is exactly what's happening for the energy vertical. Because energy, energy would be air conditioner, would be lights, would be the battery in your cell phone, right? No matter it's the Android or iOS. So this is energy. It's nothing but to generate the electrons by different physics. Then you transport electrons to where it's needed, right? Very simple. This has not been changed over the past like more than 100 years. By the way, Siemens has been doing the power business for over 100 years. And give you some number. So basically, if you look around the globe, somewhere between 20% to 25% of the energy or electricity around the globe, the Siemens technology or equipment are behind. Just give you a, and Siemens Power and Gas division is roughly 16 billion euro business. So that's some numbers you can take away. So fundamentally, the very basic need is people need power. Personally, I grew up in China. I still remember like more than 30 years ago, when the electricity was introduced to the village where I was living, it's a big thing because you can have the electric lamp, bulb, light it up. It's a big thing. And by the way, it's happening in Africa. So you have 1.2 billion people living in Africa. Half of them today do not have the electricity. So this is more like the availability of the power. Do you have it? We need power. That's first stage. The second would be taking Beijing as an example, right? The big air pollution. And a lot of researchers were doing studies, what's behind that pollution. And actually, it's very simple. If you plot this GDP growth, this coal or fossil consumption versus the air quality, it's very clear. So the next level would be you need energy in a very clean and sustainable way, right? And you add on that maybe affordable. It should be not too expensive. That's why the latest development, you see the PV, wind, drop like hell. That changes in a safe way. Now I add another 2 dimensions. That means the geographic distance. Sounds familiar, telecommunication. Where the energy has been generated versus where the energy, is needed. You are talking about the distance, right? Far or near. And people are smart. You transport coal, you transport the gas through the gas pipeline, or people are talking about the internet energy. That means the grid will literally connect every nation. So you can resolve this seasonal, the energy resource abundant nations or regions versus where you have the GDP growing. So this is a distance. That's why one transformation we're talking about is centrally large power generation versus this decentral, very flexible, a lot of, let's say, multi-model power generation or electricity generation methods. This is one dimension. The second would be storage. No matter it's battery, gigafactory here in the States, or you have this, basically we call it chemical or physical storage, right? You have a lot of synthetic fuels, hydrogen, to store the energy. Why? Because you have cheap renewables. And the time, for example, in Germany, where you need the most of energy would be the Christmas Eve, where you probably do not have so much sunshine, right? And wind might be blowing somewhere else, not nearby. So how you can basically capture the energy being generated half a year ago, and still I apply there. So those are the transformation, we're talking about here. A lot are ongoing. The whole game, the ball game will be different. Then I come back to my talk. It's very simple, the storyline. That means the energy needs to be very green and sustainable. That's why you see a lot of renewables in the whole energy mix. That triggers a lot of headaches for people who's operating. That's why the complexity has increased. Plus this geographic and time difference, or requires a lot of efforts to bring down this carbon dioxide. Because 1 kilowatt hour, imagine, right? In the States, we're talking about pounds, not kilograms. Imagine if you generate electricity based on coal, right? So 1 kilowatt hour, the carbon dioxide you are giving into the atmosphere, I give you a physical feeling. It's roughly 2 pounds, 900 grams. If you go to the grocery, you buy the vegetables or fruits. Literally, 1 kilowatt hour, you throw 2 pounds of CO2 into the air if you go by coal. Very simple. If you switch the coal to the gas, that means shale gas is a big thing in the States. Basically, this conflict between the supply and demand has transformed the whole geopolitical situation in the whole world. That can help you bring down to the 1/3 of that level. You're talking about less than one pound, 300 grams, right? And if you go with the nuclear, it's much less. Go to the renewable. If we ignore the production, right, the CO2 during the production process, you do not have any carbon footprint. So those are the first challenge. I need all of you, and we need all of you, and this whole energy sector needs all of you. How we can bring down the CO2. And the power sector, or in the plug play, you call it vertical, just one of them. You need this work together from the power to the transportation, right? The cars, even you have an e-car, and you can get away from gasoline or diesel. But there you have the big ships, doing the transportation in the ocean, and you have airplanes burning the fossil fuels as well. So transportation, power, and buildings, right? Buildings. And how across the different verticals we work together can be smarter. So that's the second idea I want you to take away. So the first would be green, bring down the CO2. The second would be how the sectors or how the verticals can work together. We need a lot of new technology, new way of doing things, right? If I'm a utility, I don't have to have all the turbines, wind turbines or solar panels or gas turbines, if we follow this Airbnb or Uber approach, right? So a lot of things can be done. The third one would be, let's say, since this transformation, the whole system, energy system, gets much more complicated than before. Many years ago, it's very simple. I transport the coal into the large power plants, I burn it, there is a steam generated, push the steam turbine, then you have the electricity, very simple. Now you see so many different ways of generating, transport, usage. And as human being, the weight of our brain is very, very light, right? Think about percentage of the whole body weight. But the energy it requires, especially, for example, we sit in such a session, hopefully you're thinking hard together with me, requires 20% of all the energy, the insects or the energy bar you're eating, you need 20% of the energy. The same applies to the energy system. That means because of its complexity, right? And you heard this AlphaGo has beaten the world champs for the Go. And the electricity bill behind one play, one chess, is $3,000 US. So that means a lot of computing power has to go into this. The same applies to the energy. To manage this complexity of the whole energy system, you need a lot of digitalization, artificial intelligence, machine learning. So all the IT topic you're talking about there, we need it to help us on the complexity. That's pretty much my talk. I still have 7 minutes. I will bore you with a few slides. Because you're either audio people, you're visual people, or you're thinking, right? Logic people. So here are a lot of data, logics, but again, follow some talking points I just shared with you. So let's quickly go through the slides. Okay, so I should change the direction. How somebody can teach me how to use it, or? Always you have backup. For energy system, we also have backup power in case you have. Absolutely, that's the key thing, the safety.
I think it's coming. They are loading it.
Yeah, it's fun. Later, I can share.
I can ask you a question meanwhile.
Go ahead.
What is your biggest challenge for now in the year 2020?
Yeah. My biggest challenge, or our biggest challenge right now, is, let's say, I call it the whole industry, are not moving faster enough to really reduce this CO2. This is the biggest challenge.
Do you agree with Mr. Trump?
Absolutely not. Yeah. So again, we call all the startups, all the people from governments, academia, and industry. Let's work together. Even dear Mr. Palm goes to left, and we believe in rights. Together, we can still make it happen. Okay. It's, by the way, covered in one of the slides. So again, energy transformation. Think about telecommunication, right? The story, the generation part. usage part, distance, geographic or time, all changing, okay? Plus green. Then a key message or trends, 3 of them. One would be literally reduce CO2. The second, I can change it to the vertical coupling, right? The power transportation. Third one would be the 20% energy. We need digitalization to really make it happen. And key message, we have to work together. And I hope this time it works. Or somebody back there can, yeah. It's very busy chart. But again, the way to read it, look at where the sources of the energy can be coal, gas, renewable, the generation part, and look at how the electron gets transported and how it gets applied. Can be electricity, can be heat, can be cold, okay? And also how you resolve this distance, geographic distance, right? You have the very high ultra voltage lines versus the decentral where it's generated, where it's get applied. And also this time, right? Basically the storage, where I can generate a lot of energy using the cheap renewables, but I can save it later, seconds, hours, days, month, or year later. So this is how you read it. And yeah, Trump. Here we are. By the way, this is not kidding. If you consider what I just told you, 1 kilowatt hour, 2 pounds. It's happening right now. Many tens of thousands CO2 are being put into the atmosphere, and it goes nowhere, by the way. It's contained in this planet. So if we do not do anything, well, I happen to see, let's say, a study. That means only the rice, we grow rice in Asia, right, gets less impacted by the 4 degree. But all the others, all the wheat, corn, all the other grains we are growing will be that, more or less. So that's seriously the world hunger problem we are talking about here. We have to get down from 35 to 25. Now this is interesting because people talking about renewable a lot. But if you consider the percentage of renewable in the whole energy, still it's a long way to go. That's why even you have this increase in the renewable installation base around the globe, but this emission is not changing that much. That means at least for now and in the next a few decades, we have to work on the vital fuel. That means we have to work on the really where the CO2 got generated and emitted. That's the whole fossil, CO2 capture, switch from coal to gas, right? And you combine this gas with a lot of batteries and cross the sectors. This is where we really spend. And this is more or less what I just told you, Yeah, this is interesting. This is so far, when people talking about CO2, it's purely you're looking at the power. That's the vertical sector down there in the bottom. But people more or less ignored all the industry, the process, right? The food, beverage is just one of them, the chemical processes, and transportation, and the building. There, actually, we need more attention. That's the key message from this chart. I go to the next one. Yeah, exactly. Think about transport, all the airplane, all the ships, all the cars we are driving. You see that orange? What if we can replace orange at least 30% by the synthetic green methanol or hydrogen? And you're going to really help a lot. So this is the message that we really try to get to you. The boundaries between the verticals are blurring, and we need to really work together. And there are ways of doing that. And one example would be, when you have excessive renewables, we can take that energy, right, to electrify the water. You have the hydrogen. Then you capture the CO2 from all the processes. Then you do the synthesis. That means you put the CO2 and hydrogen together. And again, the second time, you use the same CO2. And that can generate the power, put it back after some time, or that can power your airplane, can get your ship going on the ocean. And also, you can use all the existing infrastructure. That means the gas stations, pipelines, get your vehicles going as well. Just one example, and a lot can be done here. So I strongly encourage you to really think and how we can play. All right. The blue one would be if we follow the traditional approach. That means all the demand will grow, but by doing the old thing through the new approach, we can basically work on the two sides. That means the demand side and supply side. There's a lot of optimization can be done over there to help us on this problem. Ignore this. It's basically a lot of details go into this brain part of the energy system, you know? How you manage this complexity. It gets so complicated, how you manage it. And finally, we can work together, at least in 3 areas. All right, that's my talk, and thank you very much. We have more or less 10 colleagues from Siemens in the ground, so you're welcome to talk to them as well. Thank you very much.